Good day, my name is Altonjunior Siima. In today's video, we're going to talk about HIV. HIV, or the human immune deficiency virus, is a virus that attacks the immune system. Over time, the virus affects the immune system to a point where it can't defend itself against common illnesses. This state is known as AIDS, or in terms, acquired immune deficiency syndrome. HIV targets specific cell groups that are called CD4 cells. CD4 is a receptor that is expressed on the surface of many cells. This includes alpha T cells, macrophages, and dendritic cells. The CD4 is essential for cell-to-cell communication, hence it is important for normal function of the immune system. HIV hijacks these receptors in order to gain access to the cell. Apart from CD4 receptors, other factors called co-receptors are also required in order for HIV to enter the cell and cause an infection. Several co-receptors have been identified in different types of cell, with CXCR4 and CCR5 being the most common. CXCR4 is expressed on many T cells, but usually not on macrophages, and is usually used by T-tropic strain of HIV. CCR5 is expressed on macrophages and some T cells and is used by M-tropic strain of HIV. Some HIV strains use CCR5 for the initial infection, however, evolved to use CXCR4 later during the infection. Viruses that can use both co-receptors are called dual-tropic viruses. Some people are born with a deletion of CCR5 and are eventually resistant to HIV infection. HIV life cycle starts with the attachment of HIV envelope protein GP120 to CD4 receptors and co-receptors, followed by fusion of HIV with host cell. The virus then injects its contents, namely HIV RNA and several enzymes, into the cell. One of these enzymes, a reverse transcriptase, is used to convert HIV RNA into DNA, an important step that would allow the virus to integrate itself into the host DNA. Once in the nucleus, HIV enzyme integrase inserts the virus DNA into the DNA of the host. At this point, the virus can adopt either latent or active infection. In active infection, HIV uses the host mechanism to produce multiple copies of its RNA and proteins, which are then assembled into new virus particles ready to infect more CD4 cells. In latent infection, the virus remains integrated into the host DNA and may lie dormant for years, forming a latent HIV reserve which can reactivate and infect at a later stage in time. HIV is transmitted through infected body fluids, most commonly via sexual contact, shared contaminated needles, and from mother to child during birth as well as breastfeeding. It is not transmitted through air, thereby is not contagious. Diagnosis of HIV is by detecting viral protein, RNA, proviral DNA, and antibodies produced against HIV. At the current moment, for you to know your HIV status, you need to get an HIV test done, which takes roughly 5 minutes to complete. There are three stages of an HIV infection. The first phase, which is acute stage, generally develops within a couple of weeks after a person has been infected. During this time, patients experience flu-like symptoms. HIV multiplies rapidly, resulting in high viral loads within the blood, thereby increasing the risk of transmission. Chronic stage, also known as clinical latency, is usually asymptomatic. HIV continues to multiply, but at a much slower rate. Patients may not show any symptoms, but they can still spread the virus to others. Without treatment, the disease usually progresses to AIDS within a period of 2 to 10 years. AIDS is the final stage of an HIV infection. As the immune system continues to fail, the body cannot fight off common diseases, and opportunistic infections may take hold. AIDS is diagnosed when CD4 cell count is lower than 200 per millimeter cube, or if certain opportunistic infections are present. There is currently no cure, but treatment with antiretroviral therapy can slow down the progress of HIV to AIDS and reduce transmission risk. Antiretroviral drugs are classified according to their ability to interfere with certain stages of the HIV life cycle. There are antiretrovirus drugs that interfere with the entrance called entry and fusion inhibitors, reverse transcription inhibitors, integrasive inhibitors, and protease inhibitors. These drugs, however, cannot reach the latent virus, which hides out safely in healthy T cells but may reactivate and cause infection again. This is the major reason why HIV infection is not curable with current available treatment. Thank you for watching my video. I hope you learned a lot.